In this section of this syllabus, we're going to look more in depth at modular arithmetic, following up with our integers and different bases. Now, we looked at this a little bit in topic 4 when we looked at groups, and now we're going to go more in depth. So generally, when we think about numbers, we think about them in base 10, and that means that we're really counting in cycles of 10. But instead, we could count in cycles of 6 or 5 or any different cycle, and to do that the most easily, we could place our numbers in a table. What we see with these numbers is that if I divided any of the numbers in a single column by 6, and I'm choosing 6 because that's our cycle here, we would have the same remainder. So when I divide by 6 in this column, I'm always going to have a remainder of 1. Dividing by 6 is going to give me a remainder 2, etc. This column would give me my remainder 0. So that would give me the values of the different bases as well. We say these two numbers are congruent mod 6, because they have the same remainder. So when we define congruent mod n, it means that we have our numbers that have the same remainder. So let's go look at the typed up solutions. Oh, I thought that I had them open. I guess not. Okay, so we've got the official definition. If a is an integer, n is a positive integer, n greater than 1, our remainder, when a is divided by n, we can write that as our modular number, so a mod n. And then we've got two numbers are equal if they have the same remainder. If they have the same remainder when dividing by n, then a minus b is divisible by n. So a is equivalent. When I use my three-lined equal sign, I've got equivalence. A is equivalent to b mod n if and only if n divides a minus b. If this is true, then I could also use my division algorithm to rewrite this statement. So a is equal to b plus a multiple of n. So if they have the same remainder, then that means that they're equivalent with different multiples. Remember that congruence mod n is an equivalence relation because it's reflexive, symmetric, and transitive. So all of that ties back to our chapter 4. And in the next video, we'll look at example 1.